Hello and welcome to this this tutorial about superposition theorem. And yeah, sorry, this I think third time I'm trying to record it. I have some difficulties doing so. Anyway, so they follow two basic rules. Rule number one: voltage supply is replaced with a closed circuit. Basically, a voltage supply is replaced with a wire. Rule number two is current supply is replaced with an open circuit. So this is the current supply, it will be replaced with an open circuit instead of a wire, which will cut all the other components from that side on. Okay, so now that we know those two rules, and we have a circuit as an example, let's get started with step number one. Choose node or resistors. Now, let's see here. We'll choose these two nodes. We'll choose node A and we also choose node B. Great. Now we have to, let's choose this resistor. Let's choose I1 and I2, and you will see later why. And now step two is to redo the circuit for each resistor. In superposition theorem, we have to redo the circuit for every source. Basically, we have to do it once for the voltage source and we have to do it once for the current source. And that's why I don't think this is a great theorem. Because if you have two sources in a very big circuit with many resistors, then yes, this theorem, it really fits, it really works well. However, if you have many voltage supplies, then this theorem doesn't work. Let's say you have another two here, like you have another voltage supply and another voltage supply here, like two more. Then you'll have to redo the circuit 4 times because you need to do it for each source. While if you use like loop analysis, like mesh analysis, then you'll just loop this on once and then you take all 3 voltage sources and loop this on once and loop this on once, which will make it easier than redrawing the circuit 4 times. But it's up to the person really. But as I say, this method is not recommended. I don't really recommend it to use it often. It's good if there are 2 sources, but if there are more than 3 sources, then no, you shouldn't use this method because it will be too time consuming. Alright, so we did the first step. Let's go to step number 2 and just redraw the circuit. So let's see here. That'll be the voltage, be the 50 volts. Then we'll do the, there you go, we'll do one resistor, we'll do another one here, we'll do another one here. So I made wrong, but another one here. I said this is the third time I'm trying to do it. And these ones will be where the current was supposed to be, and it will be as an open circuit. Now there you go, we connect all of it. We put a ground here. I should put the ground here as well. There you go. And now let's write them. So this one is 10, 8, 24, 16. Now, and we have the 2 nodes A and B. Now, what we want to find out is we want to find out the current through this circuit. And the way we do it is by finding out the total resistance. And we'll take it from the right side, we'll go all the way to the left side. So we got 16 and 24. That means these two are connected in series because this circuit it's opened, so there is no current flowing through it. There's nothing in this side, so it's no longer in parallel. It's a series circuit with those two, so that will be 40 in parallel with 8. Because point A is still a junction, which means that the 14 here will be parallel with the 18 here, and that gives us 6.6. And then we'll add 10 to it. This resistor here in series, and that gives me 16.6 ohms. Okay, and therefore RT is equal with 16.6. I already know the answers for these ones because, as I said before, I did it 3 times, so now I have all the calculations and everything laid out. I'll use the same diagram as well with the answers because I don't want to do it a 4th time. Alright, if you're curious what happened, basically I was doing the calculations here and I realized that I calculated I2 wrong, and I found a way to check your answer to see if it's correct. And by the end of the exercise, like of this circuit exercise, I'll show you how to check your answers to see if you actually calculated correctly this circuit. Anyway, let's keep going. So V is equal with Ri, therefore I is equal with V over R, and therefore I total, like the total current in here, will be equal with 50 over 16.6, and that will give us 3 amps. So 3 amps is going from this direction. Good. Now we want to find out point A, and we know that point A will be equal with the difference between this resistor and the voltage source. So A will be equal with R times I. Therefore, A is equal with 10 times 3, which is equal with 30 volts. Therefore, 50 minus 30 is equal with 20. Okay, so just a second, because like my arm scratches. Okay, so A is equal with 20 volts. 20 volts, because 30 volts it's stopped by the 10 ohms. Okay, now let's see the current through this point here towards this direction and this direction. Okay, so the first current will be 20, so I will be equal with 20 divided by 8, and that one will be equal with 2.5. And then the other I is equal with 20 over 40, 24 plus 16, and that one will be equal with 0.5. Okay, so now we got the oh, is it gone? Oh my god. Okay, so we got the first current and the second current, and this current is 0.5 because there's more resistance in this, and we use the 40 ohms, and this one, this can go in this direction, and it's equal to 2.5. So current is going in this direction and this direction and this direction as well. Okay, now we need to find out the voltage for B, and the voltage for B is calculated like this. It will be equal with 16 times 0.5, and that one will be equal with 8 volts. Okay, so let's just make sure. So 2.5 times 8, that should give me 20, shouldn't it? So it's 2.5 times 8. Yes, it gives me 20 because we do 2.5 times 8. And this one will give me the voltage of B, which will be 8 volts. Why we use this resistor and not this resistor? Well, it's because this resistor, it's in a relationship with this resistor here. Because like if we use that resistor, then we'll get 12 volts here. Actually, I'll do it here. Alright, just let me do a little section for it here. Okay, so if you use this resistor, the 24 will do 24 times 0.5, which equal to 12 volts. And you're gonna say like, well, actually this is wrong because this is 8 and this is 12. So how do you know that it's 8 volts and not 12 volts? Well, let's not forget what we learned in node analysis, because I forgot that a little bit. Anyway, yeah, I realized that like another time. When I did the first time, I realized the mistake, so now I can explain to you. Well, if you remember in node analysis, you need to take away the differences, don't you? Basically, this node is going to be equal with the voltage here minus the voltage to the resistor to get to this node here, which basically will be 20 minus 12. and that will give me 8 again. So 8 is the correct answer. But why can I do this one straight on without taking away the node A? Well, the current doesn't go through node A here, does it? Because here is the ground, and we know that the ground is 0 volts. And if you do 0 minus 8, which we get here, it's still 8. This was one of the mistakes that I did the first time around. But anyway, so now let's write down the answers we get. So A1 is equal to 20, like for this one is equal with 20. B1 it's equal with 8 volts. I put the number 1 in front of them because this is the first diagram. We'll need to do a second diagram with the current source next time. Anyway, and then let's do I1, which is this one here. It's equal with 2.5, and I2 it's equal with 0.5. You'll see later on why it's important to calculate this one as well. Now, if we finish the first one, let me press a break and let me pause, and I'll get a new piece of paper, and then we'll do the second part. Okay, here's the second piece of paper, so we still have the answers from the first one. Okay, on the second one, we use the current source. So instead of the voltage, we just leave a straight line. We just repeat what we did on the previous one. So we put some resistors in here. Okay, this resistor. And then another resistor here. Another one here. Connect them together. And then here will be the current source. And here will be the ground. So this will be 5. This will be 16, 24, 8, and 10. Okay, and this will be point A, and this will be point B. Node A and node B. All right. Now, sorry, just a second. There we go. Now again, yeah, I think we should do it. Let's calculate the total resistance, and you'll see in a second why. So it will be 10 in parallel with 8, and that'll give me 4.4, and they will add by 24 this resistor here, and this one will give me 28.4. In parallel with the 16, that'll give me a total of 10.2. So it's important to know that these 3 resistors all together will give me 28.4 ohms. Because now we use a current source, we don't use a voltage source anymore. So we cannot use the same formula. We cannot use I over V, no, I equal V over R, because we do not know the voltage anymore. There's no voltage in here. Therefore, we're going to use the current. And because the current goes in this direction, then this will be 5 amps. And we need to calculate the 2 currents that go in that direction and in that direction. And we know that these 3 together are 28.4 ohms. So we'll use 24.8 ohms going in that direction. Now, let me explain how you calculate it. So first, let's draw a small diagram. There you go, that'll be 16 ohms. That'll be 28.4 ohms. And then we use this formula, I input equal with R1 over RT equal with I in R2. Basically, and we name this one R1 and we name this one R2. Now, this might sound confusing, but when you use the first resistor, you'll get the value of current on through the second resistor. And R total is the total between those 2 resistors. And they are not, we don't calculate like in parallel, we just add them together. So I'll show it to you by calculating. So the input is 5 amps. So 5 amps are coming in. This is not an equal, it's a multiply actually, sorry. 5 is coming in. We multiply by R1, which is 16, over R total. And R total, it's 44 1.4. Okay, and that one will give me 1.84 amps. No, it's only 1.8. The 4 one is from the previous one anyway. And we do the same for the other one. So 5 times 28.4 over 44.4. And that one will be equal with 3.19 amps. So we know this is correct because when we add the two of them together, it will give us 4.999 and so on, which means that these are the correct values. Now let's calculate the rest of it. So we know this one, it's 3.19 amps, which will be I2 basically, and to this one is going 1.8 because this is the high resistance in total compared to this one. Most of the less current will go in this direction. Now let's calculate it for the other two. So let's calculate it for this direction and this direction, for the one going towards the 8 and the one going towards the 10. Okay, we use the same diagram. Let's draw around the same diagram. Just make it easy on ourselves. That will be an 8, that will be a 10. This will be 8 over 18, which will be equal with 1.4. Oh yeah, we also multiply it by 3, no, by 1.8 times. Let me check if this is correct. So 1.8 times bracket 8 over 18. That give us 0.8. Sorry, that's wrong actually. Never mind. 0.8. Good thing that I stopped and checked now. So let's write here 1.8 is coming in. Okay, now let's do with the other one then. So 1.8 times 10 over 18. And this one would be equal with, so 1.8 times 10 over 18. 1. So this would be 1. I mean, it was kind of obvious to be honest, because we could have done just 0.8 minus 1.8 and that'll give us 1. But it's better to check, just making sure like everything is correct. So now we have this current as well. So this will be 1 amp and this one will be 0.8. Well, now will be easy to find the currents, not the currents, the voltages in point A and point B, because you can use the same principle as this one here. We'll multiply the current with this resistor and we'll get the nodes, and current by this resistor and get the node here. So node A will be equal with 1 times 8, and that will be equal with 8 volts. Good. Now let's do for B. B will be equal with 3.19 times 16, and that one will be equal with 3.19 times 16, 51.04. 51.04. So here point A, it's 8 volts, and this one is 51.04. Now let's write it down. So A2 it's equal with 8 volts minus 8 volts. B it's equal with minus 51.04. I1 it's equal with minus 1, and I2 it's equal with minus 3.19 amps. This one is a volt. So now you may wonder, like, why will we write a minus value instead of a plus value? Well, you see the current of the direction of the currents? This one is coming from the ground up. It's going from down up, down up. While this one from our previous one, from the very first one, is going from up to down, up to down. Which means they have different current flows. And if they have different current flows, then one of them have to be a negative value. If both of them were from up to down, and this one was up to down, then yes, we'll add them together. But they don't have the same current flow. They have different current flows. So we'll have to choose different ones. Okay, so now we'll be on our last step, and the last step will be add all the values together. So we'll do, so A will be equal with, come on, focus a bit, there you go. A will be equal with A1 plus A2. Therefore, A is equal with A1, it's 20, minus, and then is this one here, it's 8. And therefore, A is equal with 12 volts. So the value A in here, it's 12 volts. Now let's calculate the B value. It's equal with B1 plus B2. Therefore, B is equal with, what we get here, we got here an 8 volts. So 8 minus, and this B here, it's 51.04. 51.04, which will be equal with, therefore, B is equal with minus, let's see here, so 8 minus 51.04, that will give me 43.04. Okay, now this is interesting, isn't it? One node is a positive while the other node is a negative. Well, now I found that interesting as well, and I was wondering if I can check if there is a way to check the answers, because I always try to find a way to check the answers even though we don't know anything about this circuit. And then I realized that I can use the current simply, because these two will use different currents as well, which means that if my calculation is correct, then when I multiply I1 by this resistor, I'll get the value of node A. And if I put, I think I put 12 volts by mistake in there, sorry about that. Anyway, and if I do so, if the answer is correct, then that proves that I calculated properly, that my calculations are correct. However, if the answer doesn't fit the node, that means that one of my calculations in these 2 pages was wrong. And that's why it took me 3 times to do it, because I always found something that I did wrong. For example, let's say here I didn't use 28.4. I didn't use the 3 resistors. I used only these resistors, these 2 in parallel, without adding the 24. And that made all the calculation wrong, and that made the point B not match with the current. So the current multiplied by this resistor won't give me the node B. Okay, actually it's right here. So this one is supposed to be minus 43.04 volts. Okay, now let's see if our answers are correct, and hopefully they are. So I1 will be equal with 2.5 minus 1, and will give me 1.5. And now, actually, let's do for the I2 as well. So, and I2 will be equal with minus 3.19 plus 0.5, which will be equal with, just a second, 2.69. Nice. It's a minus as well. Let's not forget that, it's very important. Both of them being amps and this being volts. Okay, so we got those 2 values here. Now, let's see if the calculations are correct. We got 8 ohms in here, and we got a current I1 being 1.5. So if you do 8 times 1.5, and yeah, this one already gives, this is 12 for sure, isn't it? Times 1.5, 12 VM, 12 volts. So there you go. So for the first one, A, it's correct. It matches. However, we also need to do it for the value B as well. And if the value B as well matches, that means we did the entire process correctly. That means all the equations are correct. So let's see here. So to point B, it's the 16 ohms resistor, 16 times the current I2. And I2, it's minus 2.69. So this side is good start because it's a negative value. That means we'll get a negative number. So let's see, 16 times minus 2.69. And there we have it, 43.4 minus 43.04, which means this is correct. Okay, this is the first exercise. I think I'll do a couple more. I think I'll do 3 exercises. Okay, so overall, we learned how to calculate the nodes of the voltages. We also learned 2 methods to calculate the current. First one being using a voltage and a resistor to find out the current. And we also learned how to calculate the current split as well when having only current and voltage resistors. When we don't have a voltage, we apply this formula here, this method here. And we also need to make sure that when we calculate this bottom one, this split in here, we also need to integrate all 3 resistors here. Okay. Now I'll stop the recording here since we got the correct answers, and I'll jump to the next exercise. Hey, okay, so let's work with the second example. And I thought if I make rectangle shapes and just put the voltage and current sources, then yeah, that'd be a bit too simple. So I made these strange shapes so when you watch the videos you can get more used to them, because it kind of like trains you to like distinguish which one is in parallel and which one is in series. Because if it's in rectangle shape, then it's easy for you to tell, but being in this type of shape, it's a bit harder. Okay, so first let's get our points that we want to find out. So we want to find out this point here, point A, this one here, point B, and this one here, point C. Okay, and we can already see that we can find out the values in point B and point C by just doing these 2 resistors here. There you go, it keeps getting out the focus. I guess I'll have to be a bit further away. Anyway, okay, let's start redrawing, I guess. I really hate this. I don't like to keep redrawing. Okay, let's see. So like that, and then one down, then this way down. This one goes down as well. Let's put the ground in here. There you go. Okay, and then this one goes this way, this one goes this way, this one goes this way. Then this is an empty wire because we replaced that one. And then there you go, there's a current, and there you go. So that will be 8, that will be 6, that will be 10, that will be 12, that will be 6, 6, and 8. No, wait, actually we need to replace this one as well. So this one will be an open circuit, so there will be nothing in this direction. Okay, so far so good. So the current will go from here and it will go through here. Because there is no parallel in this resistor, it will be still 8 amps. And then the first split it does, it's around here. Let's see. So we'll need to do our method, but first it's calculated. So because it's an empty wire, this 8 ohms is in parallel with this 6 ohms. So 8 in parallel with 6. And that one will be equal with 1/8 plus 1 over 6 equal, and then 1 over the answer equal again. That will give us 3.42. Okay, and then these two are connected in series with this one, plus 6, which will be equal with 9.42. All right, so we got the 9.42 and a 12. Now let's see here, we'll do the method here. Okay, so one of them it's 12 and the other one it's 9.42. Okay, so these are the two resistors. So 8 amps are coming in, multiplied by 12 over 12 plus 9.40, that would be like 21.40, wouldn't it? And that one is equal with, so let's see, 8 times bracket 12 over 21.40. That will give us 4.5, let's say. No, let's put 4.48, just be accurate about it. Okay, and then we need to do with the other one, which will be 9.42. That will give us a 8 times 9 over 21.42. That one will give us a 3.52, and it will give us a perfect 8, which is nice. Alright, we got those two currents. So we got the current going this way, a second, so A, B, and then C. And we got a current going this way. Okay, let's see. And the 4.8 is going that way, and then the 3.52 amps is going that way. Now we need to do another split. So there you go, that would be like an 8 and a 6. Okay, that one will be 4.48 times 8 over 14, and that will give us 4.48 times 8 over 14, 2.56. And now we do with the other one, which will be 6, and that will give us 1.92. Yeah, that's good. Okay, so in this direction is the 2.56, and in this direction is the 1.92. Alright, now we know the currents, and we just need to calculate the voltages. So V is equal with R times I. This one should be pretty easy. We just do 3.52 times 12. So B1 it's equal with 3.52 times 12, which will be equal with 3.52 times 12. Sorry, my noise is sketching. 42.24. 42.24, I think it was. Let me say it again. Yeah, just a second. Okay, I'm back, and I also realized a mistake that I made. Let's just delete this point here and name this one A and name this one B, because at this point here I don't think there's anything you can find out, because like it's supplied by two current sources and the voltage is really affected, so it's like little voltage in this area here, I think. Anyway, let's see. Okay, we'll see. Anyway, so we got 42, and this one it's actually A. Okay, now let's calculate for B. And that one should be pretty simple as well, because B will be equal with a resistance times current again, which should be 6 times 2.5, isn't it? Yeah, 2.5, 6, which is equal with, so 6 times 2.56. That give us 15.36. 15.36 volts. Okay, now we'll do it again, but this time for the undercurrent source. Let's see, so we'll cut this one, so there will be nothing in this way here. So there will be the resistor, this will be the other current source, 6 here. Okay, this one will go down, it will go to this, will go to the empty wire, go this way here, and then this will be another resistor there, another resistor here, all of it connected together, it's a ground. Let's see, and the values are 10, 12, 6, 6, 8. Okay, and the 2 points A and B, A1 and B1. Okay, there you go. Let's write them down here as well. So A1 is equal with 42.24 volts. Then B1 is equal with 15.36 volts. Okay, let's see. So there's nothing, therefore the current goes up here, it goes to here, so this one will be 6 amps again, and then it will have to split again, and I think it uses the same values, doesn't it? Yeah, it does. Okay, so it will be, no, not 8, 6 times 12 over 21.42, and that one will be equal with 6 times 12 over 21.42, 3.336, so 3.36, and then we do 6 minus the answer, so we don't need to calculate again, that'll be 2.64. Okay, and then okay, so the 2.64 goes in this way, 2.64, and then in this way it goes the 3.36. We do it again, but this time with 3.36 times 8 over 14, which is equal with, so 3.36 times 8 over 14, that'll be 1.92, and then the other one is 3.36 minus 1.92. So you don't see the computer calculator, and that'll be 1.44. 1.44. That does actually give us 3.92 plus 1.44. Yes, it does. 36.36. Yeah. All right. So now we have the currents again. So the smaller one will go to the bigger resistor, so there'll be 1.44, and this one will be 1.92. Okay, now let's find out the points. So A2 will be equal with 12 times 2.64, which is equal with 12 times 2.64, 31.68, and then B2 it's equal with 6 times 1.92, which is equal with, so 6 times 1.92, 11.55, 11.52 volts. Okay, so it is going in the same direction. Okay, so it is a plus value. That's good. So A2 it's equal with 12 no, 31.68, and then P2 it's equal with 11.52. Okay, let me go to the next page now. So I'll pause here. Okay, I'm back with the blank page now. So let's keep going then. Now we need to do for the last one, which will be the voltage supply. And that one will be, so there will be a short. There will be the resistor. There you go, so you can see. And there we go, be another short here. Which means that, wait a second, let me like finish drawing it. So that is the 30 volts plus minus. There is the 12. There is the 6. So there's the 10, 12, 6, 6, 8. Okay, now here is something interesting. Those two are open circuits, yeah? Well, that means there is no current through this resistor here. Why? Well, because, wait a second, there you go, A and B. Well, because there is no flow for the current. The current can't come in and just wait here. No, if there isn't an end goal, if there isn't a ground or like a source, then the current won't be allowed to go through this way. Okay, now it will make us the calculation easier because we'll calculate from these two. We need to calculate the total resistance because we have a voltage source. So we will start from this side to this side, like that, from left to right. So 12 plus 6, that will give us 18, and then that 18 is in parallel with the 6. Okay, and that one will be equal with, let's see here, 1 over 18 plus 1 over 6, and then 1 over the answer, and this will give us 4.5, which is correct. It's more than 6, so 4.5, and we'll add up with 8 plus 8, and that will give us 12.5 ohms. RT is equal with 12.5, therefore I will be equal with, okay, what's the formula? VRI, so I will be equal with V over R. So that will be 30 over 12.5. That will be equal with, so 30 divided by 12.5, 2.4 amps. 2.4 amps in total. So this 2.4 going that way, 2.4 going this way, and now they will split there, and when they split we can do the same that we did before. Actually, really, you can just do this one, and then we'll have here these two are together in series, so they'll be like 18 and this one will be 6. Okay, and then we do 2.4 times 6 over 24, and that will give us 2.4 times 6 over 24, 0.6, which means the other one, 2.4 times 18 over 24, 1.8. Yeah, and that those are the two ones. So 0.6 is going in that direction, 0.6 the direction there, and then the other one, the 1.8, is going in this direction down here. Okay, now let's see. So we can easily calculate the voltage now by, at least for P, so B will be equal with R times I, which will be equal with 6 times 1.8. That one is equal with, so 6 times 1.8, 10.8. Wow, but oh wait, actually look at that, like all of them have the same flow in this one, which means that all of them are going to be positive, and that's good. Anyway, okay, that's for like B3, and then A3 it's equal with, let's do like brackets, 12 times 0.6 plus, no, that's it actually, because they are in series, so they use the same current. Okay, and that will be equal with, let's see, 12 times 0.6, 7.2 volts. Okay, 7.2 volts. Well, this actually makes sense because, yeah, there isn't that much, is it? Okay, so, and because we use the current, everything should be fine in here as well. Okay, now let's see. So A1 plus A2 plus A3 will be equal with A, and B1 plus B2 plus B3 it's going to equal B. So 42.24 plus 31.68 plus 7.2, it's equal with, see here, so 42.24 plus 31.68 plus 7.2, 81.12, 81.12. All right, and now let's do for B. So B will be something like 15.36 plus, and then 11.52 plus 10.8 equal, this one is smaller, so 0.36 plus 11.52 plus 10.8, that will give us 37.68. 37.68. All right, now let's try with the current, since we have all of them, and since all of them follow the same direction. So we got 2.56. We also got plus 1.92 plus 1.8. All right, so 2.56 plus 1.92 plus 1.8, it's equal with 6.28. And let's see, 6.28 times 6. Oh my god, it actually worked. You have no idea how stressed I was. I was so afraid that it won't give me the answer. So we calculate the current. This one is like I2, it's like for B basically. And then when you do 6.28 multiplied by 6, the resistance of B, it gives you 37.68, the same answer. That means that at least this node B is correct. Now let's see for node A. Let's see here. So for A, we have 3.52. So 3.52. We also have 2.64 plus, and then the last one was 0.6, I think, yeah, 0.6, and all together will be equal with, so 3.52 plus 2.64 plus 0.6, that one will give me 6.76. 6.76, and we multiply that one by 12, and that will be equal with, so times 12, 81.12. Again, the same answer. Okay, so this is how you do it with three how is it called, the three sources. And again, if you are not sure of the answer, if the answer is correct or not, if you did a calculation wrong along the way, then you can use the method that I used here. Because again, if you give to a different value, that means it's wrong. Anyway, that was example 2. I think I'll do one more short example, and so it's like 3 examples like usual, and that will be the video. I don't know, I always thought, like, as you can see, superposition can be easy when once you learn how to do it, like once you understand the basics of it. But I didn't expect the video to take again 55 minutes. It took even longer to make, to be honest. Especially that I had like to do previous tries and I had to like come out with like something random. I mean, it sounds easy to come out with something random, but it has to make sense a little bit as well, doesn't it? What am I saying? I get values like 81 volts, 0.12. It's not like I'm making sure that they are round numbers. Anyway, I mean, if you want to try for yourself, see if you can get it right, you can like take one of my circuits and just replace the value of the resistors and the currents and the voltage sources with like random numbers, and then calculate the random numbers and see if you get like the correct answer like me, like if it checks out. I think that's a better way to learn from it, you know, especially after you watch the video. Anyway, now I'll jump on to example number 3. I'll get that done ready, and then that'll be the end of the video. Hi, this is the last exercise for this tutorial, and unfortunately it's really cloudy outside, like it got dark, so I had to use my light bulb, and yeah, as you can see, yeah, it isn't very good, is it? Anyway, you can see the shadows from my phone and everything. Anyway, let's finish this one quickly, and because I want to show you why the 2 rules that I told you about are very important, not only to solve the circuit in general, but also how it affects the circuit in certain conditions, and you'll see in a second. So let's call this one A, and we'll call this one B, and we'll try to find these two. So that should be simple enough. Now let's redraw the circuit. So there you go. We'll do one like this, and then we'll do this, and then this. Okay, another one here, another one here, and then these two are short-circuited, so there is nothing, and then there is another one here. 10, 15, 20, 10, 10, and 5. Okay, now let's see, so let's calculate it from this side that way. So that would be 10 and 15 in parallel, so 10 and 15 in parallel, and that will be equal with, 1 over 10 plus 1 over 15. That would be 0, and then 1 over the answer, and that would be 6. Okay, so we got 6 in here, then these two become in series, so like plus 20, that would be 26 in parallel with 10 again, and then when you parallel with 10, so it'd be 1 over 26 plus 1 over 10, then 1 over the answer, that would be 7.2 ohms. So this side it's 7.2 with the points A and B. This point A, this is the point B. And if I'm not wrong, I think I can do it one more in parallel with the 5. That would be equal with, so let's see, 1 over 7.2 plus 1 over 5. So that, and then 1 over the answer, and that's 2.95. So 2.95 ohms. So that's the total resistance, and then the current will be equal with 10 over 2.95, which is equal with, so let's see, so 10 over 2.95, 3.389, okay, it's 3.34 amps. Okay, we have the current, and then now we just need to calculate, so it will split in two in here. So this current will go like this area, which is 7.2, so 7.2, and then this one, which is 5, connect them together, and then it's like 3.34 times 7.2 over 12.2, which is equal with 3.34 times 7.2, that's it, 7.2 over 12.2. Now it's 1.97, and we do 3.34 minus 1.97, that will give us 1.337. Okay, just a second, I got something in my eye, and I need to find to hold the phone as well. There you go. Alright, so the 1.97 is goes to the 5, so 1.97, and then in this direction goes the 1.37. Okay, and it splits again, so it will be 26 because it will be these three resistors and this one. So 26, and then this one, which is the 10, and to be 1.37 times 26 over 36, which is equal with, so 1.37 times 26 over 36 is equal with 0.989, so we can put like 0.99 really. Okay, and then that means the other one it's 1.37 minus 0.99, that one it's 0.38. Okay, so through this one it's a current of 0.99. Through this one it's current of 0.38, and now we need to do the last one, which is through B, and which is through 15 and through 10. Let's use both of them. Okay, I'm writing so ugly because I'm trying to finish it as fast as I can, because this video is long enough already. I don't want to be any longer. So 38 times 15 over 25, which is equal with, so answer times 15 over 25, that gives us 0.228. Let's put like 0.23, and then 0.38 minus 0.23. I mean, the other one doesn't really matter, it's 0.15. Okay, so this one here to be equals 0.23. Alright, so this one was the first one. Now we just need to calculate. So 10 times 0.99, that will be 9.9 volts. So A it's equal with 9.9. Let's just write the entire thing actually. 10 times 0.99, and that is equal with 9.9 volts. And then B it's equal with 0.23 times 15 the resistance, which is equal with, so 0.23 times 15, that's 3.45 volts, 3.45 volts. All right, I'm using 10 volts, so this seems about right, to be honest. Anyway, okay, let's see. So let's write it down here. A is equal with 10 times 0.99, and then B11 is equal with 0, no, it's equal with 3.45. Sorry, actually this is just 999.9 volts. There you go. Okay, I'll pause and take a new page. All right, now let's get to the next one. So now we replace the voltage source with a wire, so it will be like this. Then it will be a blank wire, that'll be 5, and then one here, that'll be A, this will be 10, this will be 20, this will be 15, this will be a line here, this will be a circle here for the current going that direction, 5 amps, and there will be a 10 in here. Okay, so it's going in this direction, it will split in two. But here's the interesting part. Now, as you can see here, there's no resistance in this wire, yes? That means this is a short circuit. And theoretically it's a short circuit. So all the current is going through this wire only. Even though these three are in parallel, only this wire is getting all the current. So the current will go in this direction, and it will go here and here to the ground, which will make it all of them in series. Interesting, isn't it? Because by taking out the voltage source, we literally made a short circuit here, and the only current going through these two, these ones, and also through this one like that here, I think it to go through them, is because of the short here. And that's what I wanted to show you. I wanted to show that if you don't follow the rules, or if you misplace them, even in big circuits, like, they make a huge difference. And also it's important to know about like the effects of open and closed circuits and what they mean. Because an open circuit means they will take all the voltage in if they are like this, you know. Anyway, let's we didn't really see the effects of them before, because in the other ones you're connected in series with something else as well, with a resistor, let's say, but this one is not connected in series with any resistor, and that's how the short appears. I'm not sure if the answers will be correct, to be honest. We'll see. Anyway, so then we'll have here 35, so those two are 35 together, and then this is going to be as well, and then this one will be the 10, so 35, and then there will be the 10, and the 5 are coming in. Okay, so it will be 5 times 10 over 45, and that will be equal with, let's see here, so 5 times 10 over 45, that is equal with 1.1 amps. 1.1 amps. So 1.1 amps going this way, and then the other 3.9 amps are going that way. And it makes sense. I mean, this one, it is like 3 times bigger than this one, 3 times and a bit bigger than this one. So that seems correct. And now, here's the interesting part that I want to check. So it does work actually, because the first one, actually let's calculate B, and then B will be equal with 1.1 times 15, and it will be equal with, why is it like only 150? 1.1, no, not 150 times 15, yeah, 16.5. 16.5 volts, and this one will be B2. And then A2, it's equal to 0 volts because there is no current going through this point here. Therefore, there is no drop in the voltage drop in this point. Okay. So let's check the answers then. Show me. So A, it's equal with 9.9 plus 0, which is equal with 9.9. And then B, it's equal with 3.45 plus 16.5. And together it will be 19.95. Okay, and then the currents. So there is one current going up and there is one current going down. So one of them has to have a minus value. So it will be 1.1 minus 0.23. And that one will give 1.1 minus 0.23. 0.87. Okay, and then we do 15. Oh no! Yes, because one of them, yes, of course, because this one is negative, we choose this one to be the negative, that means the 3.45 is negative as well. Sorry about that. So that means the B value is not 19.95, it's actually 6.5 minus 3.45, 13.05. So 13.05. Okay, and this is the amps. And now let's check our answers. So for node A, it's pretty simple. It's basically 9.9 times, no, 0.99 times 10, which obviously will give us 9.9, because again, in the second one, there is nothing going through it. And for B, it's equal with, we got 0.87 times 15. And this should give us the right answer as well. So 0.87 times 15. There you go, 13.5, the correct answer. 0.5 volts and volts. So these are the answers. This is how you do this question, where you create your own short circuit. And yeah, this made the calculation a lot easier, to be honest, and like less error in it. And sorry for the poor quality of the third one. It's just I ran out of the time and I really wanted to finish this video today, but yeah, that's fine. Okay, I was thinking, I think next week I might do Thevenin analysis, where you take one resistor and you pretend that resistor it's actually a voltmeter, and then you'll make any complex circuit in a simple series circuit with one source, voltage or current source, and one resistor, and two resistors actually, theoretically, but still, and that's it, which will make it a lot easier. I was thinking about doing that one next week, or I was thinking about doing delta to gamma. Was it called gamma? No, delta to y, I think it was called. Yeah, it's delta to y. I was thinking about doing delta to y transformation to teach you how to transform circuits. For example, you can transform this here in a y. So instead of having 2 points, you can transform it in a y and have it only 1 point, you know. Or was that in a delta? I need to revise that one as well. I haven't used it that much, to be honest, during the year. I know like delta y transformations are very important in certain circuits to simplify it, but it's not always necessary. Anyway, yeah. And my opinion on this method of doing circuit, I find it very good for like beginning, to be honest. And I mean, yeah, I'm a beginner. I'm like in my first year of university, barely finished it. But I think this is kind of useful for the start of it, or for small circuits. As I said, it's useful as long as you have two voltage sources. But I imagine like further in the future, we won't use this one as often because I imagine there'll be more than two voltage sources that you need to calculate. And also I imagine that, yeah, these resistors are put nicely in like how is it called, they are put nicely like that in rectangles, but I don't know, what if they are capacitors or inductors or amplifiers even. I mean, if you have an amplifier, I don't think you can really use superposition to calculate it, can you? That's how you do Thevenin equation as well, the Thevenin analysis, because use Thevenin analysis to do the amplifiers, the op amps calculations, which I find interesting. But yeah, and hopefully I'll be done by next week. I also started doing some like other courses as well. It was like that MIT thing with courses and they give you the certificates. Man, like they are so expensive though. The university gave me like one of them for free and gave me another two of them for free for doing a survey. But they are like £170. And it's so little content as well. I mean, yeah, they have like a few videos, they have like 10 videos, but they're like only 5 minutes long. Even my videos are longer than theirs. And it just goes over it by a little bit. And it's not like a year-long course or anything like that, or a month-long. Yeah, it is a month-long course actually. It's not like 2 or 3 months long course or like something that goes in very great detail. It's more like every week you get a homework, and then at the end of the month, no, not at the end of the month, a month in the future, you will do the exam, and then you see if you get the certificate or not. And that doesn't bother me though. Like if it was 170 for like an entire course, that'd be fine. The problem is like it's split in three parts. It's like the beginner one, the intermediate, and then is the word application one. And all three of them are kind of like in the same course, but each one of them it's 170 pounds. And I use my code to like get those three and revise on them, to be honest, because I don't know. I find knowing this stuff well being a lot more important than knowing complex stuff, the basics of complex stuff. Because if you understand this, then it will be very simple to do complex things and calculate. As I said, with the example of the op amplifier, you have the op amplifier and it won't be like as straightforward as this. But by knowing the principles and how it works and how you can do it, then yeah, it will be a lot easier. Anyway, so this was the tutorial for this week, and I guess it's a bit longer than the previous one. I don't know, I like to keep them, I like them they are an hour long because I know I like to give 3 examples, and I like to give the examples like being very different between each other as well. Usually when I watch on YouTube like any tutorials, they always give you like simple examples, and even in the manuals as well, in the books and everywhere. When they give you the example, they give you something very simple and very easy to comprehend, but then you do the problems and they are too hard. Anyway, that's the video. Bye.